So guys, welcome to a new video from JangaFX. Today I'd like to talk about LiquidGen again. We are back to talk about LiquidGen because yesterday JangaFX released a new build. We are talking about the LiquidGen 0.3.1 alpha. We prepared some tutorials in the past about the older version, and it was really great. We done some really nice stuff. By the way, I like to have a first hand on this new version. You can download it and you can install it. If you have the old one, you have just to launch LiquidGen, and then it will ask if you like to update the software. By the way, there are some new features. You see something related to the import-export. We have some new improvement on the data exported about the speed. We have some feature about the frame rate compensation in the liquid that is exported. And you see we have some more information related, some new feature and improvements about the memory. There are some improvements over the simulation and rendering. They say that the photo mapping and the path tracer is faster, and then they have a new denoiser. They say that the solver of the white water is impacting less on the simulation time when you see it is far from the main liquid, and they say that the collision is improved when you have collision with the ground. There are a lot of improvements over the UI, you can see, and a lot of bug fixes as always. So if you go to log LiquidGen, it will ask for the update. We just done it, so we have the new version installed, and I like just to play with it to see if the stuff are working in a better way. So let's imagine that we go to have a new project. As always, you see that this one is the first one. We are working on a RTX 3090, so it's a fast video board, but it's not so fast. So let's remove for the moment the stats, and we can see something related to the scene. So let's do something simple. So for example, let's pick this one and say that it's bigger, to something like that. So let's say maybe 20 meters. It is bigger to create something like a pool, and we go up, and then we go to move this one. So press R. If we press space, you see that it's starting to simulate. I have to say that it seems faster than the previous version. Maybe it's not like that, but it seems faster. So let's remove the live so we can try to fill the container here. So to do something like that, we can say that the emitter is animated, and let's say that here it is on, and then let's say that, for example, at 301 it is off. So first of all, the first thing we see is that we have the particles coming down, and then we have no more emission. By the way, we have the live, so we have to go here and say, okay, let's not add live to the particles. If we go to simulate, it is going to simulate, then it falls down, and then it's over. It says that it is out of the virtual domain, so the particles were removed, and that's okay for us, it's not a problem. So let's go to pick a different lighting. So let's say HDR. I like to see in general if it is a little bit faster than the previous version or not, and the ground can be something like a dark ground. We have the reflection, but if we like, we can remove it, it's not a problem. So and you see that everything goes really smooth. We have some strange splashes, but the strange splashes are due to the setup here. And the first thing I like to see is, first of all, let's go for something more complex with 4 sub-steps. We get to simulate, it's a little bit slower than before. But in this way, you see that we are going to create some really nice behavior in the water. So we have to remove, for example, the particles out of there. And to do something like that, we can also add, for example, a drain. Remember that we are using an alpha version, so you know, it can crash always. So let's say that we like to see the primitives, and let's go, this one is 20 meters, let's go for 22, 25, maybe just a little bit bigger, 27. Invert shape, and say that is not visible. It's still simulating, but now we are removing the particles out of there. Just to be sure, I go to save this one like first and done. Okay. They say, for example, the first thing, let's say that the path tracer is faster and thus it's on Denoiser. So if we go in the render, you see that as always we have the possibility to have a better rendering with a better sampling, and it works nicely as always. And then we have stuff for the path tracer. So let's say that we have now for the mapping, for example, and we go here. This is the new path tracer. So you see that we have the Denoiser that is behaving in a really nice way. And I have to say that before it was, I have to say, really slow over my 3090. Obviously it is related to my video board, but I have to say that now it is a pleasure because it's really, the quality is really high, and now it moves faster than before and smoother, and the Denoiser is really helpful. When I had, for example, the photo mapping, it was like a pain to use it, but you know, using the Denoiser gives us the possibility to be really fast, also with this option activated. And you have not to take care about it. You see, in this way we have no Denoiser, and I have to say that it's still faster than before. So not sure if they worked more on the Denoiser, but it is better than before. So with the 4090 everything will be really smooth. Let's go back to have no path tracer. Obviously the quality is lower, but you see that's really fast. Let's go in the liquid appearance to tweak a little bit to have a little bit more absorption. Okay, and I have to say that the quality of the simulation is really not bad. Let's say that we have another force. This one is the gravity. Let's go to add another force, and let's say that we have maybe a toroidal. Okay, and we see that the twist is really high. Let's go to see what happened. You see that everything is rotating really fast, but we say that this one is not active. So let's go to animate, back to the first frame, and we see that this one is not active, and we go to activate this one to, for example, 400. Okay, Control S to save. Let's go to have a lower quality in the simulation just to make a really simple and fast preview. We have the emission. Okay, we have some strange behavior, but it's not a problem because that's really fast. And then you see this starting to have this kind of twister. So what I like to do is, first of all, let's say that the energy is lower, and then we go to have a fall off that is linear, so the energy is falling down. Okay, so let's see in this way if it is better. We have the simulation and it is falling. Then we have the toroidal forces in the middle with some really nice waves. Okay, I think that's really nice. Something new about the the white water. Let's go to add a white water, and then let's say that we have the source, and the white water is essentially with no mask. So we are just saying that we like to have the white water. Let's see how it looks. And in general, I think it is more stable, and the quality is really, really high. So it seems really amazing what we can do, and actually if we double check the stats to see how this is going, we're not using so much memory, we're not using so much energy in general to simulate something like that. You know, maybe if you like, first of all, let's go in this force. Let's say also maybe we can also try to do something else, like having something like that, so the forces is falling also sorry, on the ground. Let's go back and we'll try to simulate again. Everything is really smooth, and also the interface is really smooth. Everything works like a really stable build. Yeah, that's really nice. You see that we have the vortex in the middle. Okay, let's see what happens if we go back to something that is more complex, and save and simulate. We have not so much particles. You see it's visible here. Obviously the dynamic behavior is different than before, so it is maybe in any way more detailed. And remember that you have always the possibility to switch between a full flip to something that is more similar to an epic simulator. So you can do something to take care about all the splashes that it is creating at the moment. Obviously it is lower, but I have to say that it's really amazing that this one is working on my GPU. Really, really great. And now you see that we have the vortex that is starting to play over the water. If we go here, we can ask to have a little bit of roughness, to have a different behavior for the reflectivity. And we can have also a little bit less transparency inside using the absorption. Also the possibility to see data is, I have to say that it's more stable than before. So it is moving forward better and better. You see that we have all the data related to the parameters to control the white water. Let's go back to have it. If you like, you can have also the masking, and you see we have everything is working like a really nice simulator. Okay, spacebar. Let's make the stuff more complex. Let's add the turbulence. The turbulence is adding turbulence to the simulation, so it will be a little bit more chaotic than before, and in some cases it is something that can add more details, you know. I don't want to have too much chaos, so we will see in a few if it is too much or not. Because I want to have not so much chaos when, you know, when we have just the toroidal force that is applied. By the way, it is nice to see how it is looking in the simulation. Really amazing. This one is essentially real time. That's really crazy, guys. You see how many details we have over the surface at the moment. Okay, let's stop. And in the turbulence, we go just to have more octave, just a little bit bigger scale, and we go lower with the amplitude because I want to have less turbulence. And then to have more particles, we can go in the emitter and say that it's emitting 2 meters in the flow rate. So you see that we have more particles. With more particles, obviously, we have something that is more detailed than before. We are using a higher number of particles, so we have to see if we reach the maximum number of particles we can use. And also, let's see in the shaping here if we can tweak a little bit the fluid. Maybe just with a, you know, a little bit higher SDF smoothing. Okay. And Control S. And then it can continue with the simulation. That's really amazing, guys. It works like a charm. I think the guys in JangaFX are doing a really great job. Obviously, we can try to rise up the number of particles because actually it's using around 3 million particles, and the fluid is not bad. But maybe, you know, we need something more complex. If we like to go for something more complex, you have essentially to go in the emitter and say that we are going to emit more particles. Let's say, for example, 3 and R and press. And it is possible that we are going to reach the maximum number of particles. Let's wait. I think it's nice to see this one, for example, with a path tracer. Yeah, that's really great, guys. Okay, back with the no path tracer. And see what's going on. I think that's okay. We are around 4 million particles, so it seems something that can work. For example, this distance, you know, we don't need so much resolution. In this case, for example. Now it should stop the emission here, and then we should see how it's working about, you know, the turbulence and the toroidal force. Okay, we are okay with the particles, so if we like to rise up a little bit of quality, we can go higher. But in this case, we have to have the possibility to the simulation to use more particles. So let's stop. Let's go here, and the simulation actually we have the number of voxel is 64 millions, and the voxel are not so high, so we can stay with this one. Let's say that about the particles, we like to reach maximum 10 million particles. So we have a little bit of space to go higher with the volume, Control S, R, and press space. It will be slower, but I like to see if we can use this amount of particles. If you like to have a little bit less splashing here, a really simple way is to add, for example, a drag. Let's try to have it really low. Maybe we have to make it lower because I don't want to have too much drag, just a little bit. So let's see how the particles are moving. That's too much. Let's go to 0.25, just a little bit. And I'm not taking care for the moment about the white water. We can add also more white water. So you see we have the splashing, but it's a little bit less than before. And about the splashing, let's go higher also there. About the white water, we have speed. So let's say that, okay, that's too much. Maximum 10 millions. And save. Okay, I think we can essentially render this one to see how it looks, and I like just to double check here, and yeah, in general it's working better. There are, you see, the possibility to work in a different way with a UI of the white water. There are a lot of it is more responsive during the rendering, and that's for sure right, because I made a test before, and that's really better than before. It seems they've done not so much for the new feature, but I have to say that in general it works better. So I think they are doing a really great job. So what about the camera? Let's go in the camera here and say that the camera is, let's say, 70-20. And let's go for something like that. Okay, so that's the camera we are using. And about the export, let's say it's a sequence. Let's go for 70-20. And let's say that we go to export, for example, 1200 frames. And that's just a test, so I'm going to export everything here and say LiquiGen 0.3.1. Okay, and that's okay in this way. And let's use our 4 numbering for the frame, and that's all. Control S and export. I stopped because we have to set this one to render viewport, so we are using this this setup. And again, export, yeah, we like to overwrite, and we have the same. I have to say that in general it seems that the workstation is not blocked by the rendering and the simulation. Everything seems smoother also in this situation. Okay, let's wait for, you see the simulation and the rendering, and then we see the result in a few minutes, because you see that's really fast. So guys, simulation is done, rendering is done. Let's see the final result. And you see this working like a charm. I think it's really great. Obviously, that's not a really super high quality simulation setup, because you know we should work on having better white water, better resolution, working on the forces and stuff like that. But I think that LiquidGen is going to be really a masterpiece of software for real-time fluid dynamic. It was something amazing when they said we are working on LiquidGen, and it is going to be better and better. So we are still on the version alpha 0.3. So Let's see what's going on in the future, and let's see when we'll have the final version of LiquidGen to see what will be possible with this amazing piece of software. So guys, we'll be back on LiquidGen to finish the water sphere tutorial series, and then we'll play with something new to show you the software. Bye!